Welcome to Pawan Studies.
If you have any doubts, then ask in comments. We will clarify your doubts. This lesson important key points PDF link is given in the description.
Hello students, welcome to physical science class. Today we will discuss about human eye and the colorful world. Our eye works on the principle of sensation of vision, and we can see the objects because the scattered light of the objects will be fall on our eye, so we can see the objects clearly. Now we will discuss about least distance of distinct vision and angle of vision through an activities. First, I would like to say an activity to show about least distance of distinct vision. Take your textbook and try to read out the letters in your textbook. You can easily read out it. Now, bring your textbook close to your eyes like this. You can't see the letters in your textbook clearly, and you will be stressed while seeing these letters. Now move back this textbook slowly like this until you can see the letters without stress. Now ask your friend to measure the distance between your eye and your textbook with a scale. Now repeat the same activity with your friends also. Now we will do an average of all these measurements which you have done, and the rough value of this will become 25 centimeters. That means the least distance of distinct vision of human eye is 25 centimeters, and it will be 7 to 8 centimeters in children who below 10 years, because their muscles will be elastic and also their muscle can bear the stress to see that object, and at the same time the least distance of distinct vision of old people will be more. That means 100 meters to 200 meters or even more. That means 1 or 2 meters. Now we will know about the definition of least distance of distinct vision. The least distance at which we can see the objects clearly is called least distance of distinct vision. Now we will discuss about angle of vision through an activity. Collect 3 or 4 pipes or wooden sticks of 20 centimeters, 30 centimeters, 35 centimeters, 40 centimeters and 50 centimeters. Now place a retort stand on the table and place your head beyond the retort stand as shown in the figure. Now take a help of your friend to tie the wooden stick of 20 centimeters at a distance of 25 centimeters as shown in the figure. Now you will try to see the object wooden stick without changing your eyes. You can't see the full object, and now adjust the wooden stick by the help of your friend until you can see the whole wooden stick without changing your eyes. Note that distance, and at the same place now take another wooden stick of more length, that is 30 centimeters or 40 centimeters or 50 centimeters. Now we cannot see the full wooden stick because there is a specific value that human eye can see, that is 60 degrees. That means the person can see the whole object which is at 60 degrees. The angle of vision means the maximum angle at which eye lens can see the image is called angle of vision. Now we will discuss about Structure of human eye. Human eye is one of the best sense organ in our body. That's why our elders said Sarvendriyanam Nayanam Pradhanam. Our human eye is in spherical shape. In front, it will be more sharply curved because of the presence of transparent protective membrane called as cornea. Behind this cornea, there is a place filled with aqueous humor, and behind this aqueous humor, there is a crystalline lens which is responsible for the image formation. And the cornea is the visible part from the outside of the eye. And between this crystalline lens and aqueous humor, there is a membrane is called iris, which has a small hole called as pupil. Pupil appears to be black because the light which enters into the pupil cannot come back. So pupil appears to be black, and iris is the colored part of the eye. And iris makes the pupil to work as variable aperture. In low light condition, iris makes the pupil to expand to control the light to enter more amount of light into our eye through pupil. At the same time, in high light condition, iris makes the pupil to contrast to control the light to enter some amount of light through this pupil. So, iris makes the pupil to work as variable aperture. And there is a delicate membrane called as retina, which is a distance of 2.5 centimeters from the lens, where the image will be formed. That means the focal length of our eye will be 2.5 centimeters. That means any object at any distance from your eye, but the image distance will be 2.5 centimeters in our eye. But how the focal length will be changed from seeing distant objects and seeing near objects? It is because there is a muscle called as ciliary muscles, which will be used to change the focal length of our eye. If we see far objects, the ciliary muscles will be relaxing. So the focal length of eye will be increases. So we can see the distant objects clearly. At the same time, when we see the near objects, ciliary muscles will be strained. So the focal length will be decreases. So we can see the near objects clearly. And the ability of eye lens to adjust the focal length is called accommodation of lens. Delicate membrane, which consists of 125 million receptors, which is namely two types. They are rods and cones. Rods help us to identify the intensity of light, whereas the cones help us to identify the color of the light. The signals which is observed by rods and cones can be transmitted to brain through 1 million optic nerves. After sending these signals to brain, the brain will be analyzed and it will be sent to us the size of the object, the color of the object, etc. And now we will discuss about the three types of vision defects of human. They are myopia, hypermetropia and presbyopia. Now we will discuss about myopia. Persons suffering from myopia cannot see far objects clearly, but can see near objects. Person having far point. What is meant by far point? The maximum distance at which eye lens can form image on the retina is called far point. Myopia is also called as nearsightedness. For example, if a person cannot see the letters on the blackboard, that means he is suffering from the myopia. And the maximum focal length of the eye lens will be decreases. so image form before the retina. So the person cannot see the far objects clearly. To correct this type of vision defects, the person needs to use biconcave lens. The ray diagrams of the person suffering from myopia and the correction will be shown on the screen. Now we will discuss about another type of defect called as hypermetropia. The person who is suffering from not see the near objects clearly but can see far objects. It is also called as farsightedness. Person having near point. What is meant by near point? The least distance at which islets can form image on the retina is called near point. Minimum focal length of the islets will be increases, so image form beyond the retina. To correct this type of vision defect, the person needs to use biconvex lens. Now we will discuss about another type of defect called as presbyopia. What is meant by presbyopia? Presbyopia is a vision defect which occurs due to the aging. Presbyopia is usually occurs in the oldest people because the elastic nature of ciliary muscles will be reduced, so it cannot be able to adjust the focal length. So this type of disease is called presbyopia, and sometimes the person may suffer both myopia and hypermetropia. And to correct this type of vision defects, the person needs to use bifocal lens, which consists of concave lens in the upper side and convex lens at lower side. Now we will discuss about power. The degree of convergence or divergence of the lens can be determined as its power. But what is meant by power? The reciprocal of focal length is called power. That means power is equal to 1 by focal length. The units of power is diopter. It is denoted by capital D. The formula for finding the focal length of biconcave lens is F is equal to minus D, where minus indicates biconcave lens or myopia disease. And to find the focal length of biconvex lens, the formula is 25D by D minus 25 is equal to F. And now we will discuss about the prism. What is meant by prism? Prism is a transparent material bounded by at least two inclined planes making a certain angle is called prism. Now we will discuss about a lab activity to find the refractive index of the prism. To do this activity, we need some materials like prism, white chart of 20 to 20 centimeters, pins, pencil, scale and protractor. Take a prism and place it on a white chart such that the triangular base of the prism on the white chart. Now draw the outline of this prism, which gives an equilateral triangle as shown in the screen. Name the vertices as P, Q and R. Now measure the angle between PQ and PR, which gives the angle of prism. That means angle of prism means the angle between two inclined planes in a prism is called angle of prism. Now let us consider a ray AB incident on PQ and mark the point as M. Now draw a normal at M. Now using a pencil, draw a incident ray which gives angle 30 degrees from the normal. That means the incident angle will be 30 degrees. What is meant by angle of incidence? The angle between incident ray and the normal is called angle of incident angle. Now take two pins and place it on the incident ray A, B. Now try to see these two pins from this one side of the prism and where it appears on the other side. Now place two pins where they will appear. Name the points as C and D. Now draw a line which pass through C and D pins. Now draw a normal where it incident on PR and name it as N. The CD ray will be emergent ray and the angle between the emergent ray and normal is called angle of emergence or emergence angle. Now extend both rays till they meet at the point O. The angle O is called the angle of deviation. That means the angle between incident ray and emergent ray is called angle of deviation. Now tabulate the readings as the following by taking angle of incidence, angle of emergence and angle of deviation. When the angle of incidence changes, the angle of deviation also changes. Now plot a graph between angle of incidence and angle of deviation, which gives the minimum angle of deviation as shown on the screen. Now the formula for finding the refractive index of the prism is sin A plus D by 2 by sin A by 2, where A is equal to angle of prism and D is equal to minimum angle of deviation of the prism. Now we will discuss about two activities. Now I would like to explain an activity, but this experiment will be done in the dark room. Select a white wall in the dark room and place a table near the white wall. Now take a wooden plank and make a small hole in it. Now place a prism in between the white colored wall and this wooden plank. Now focus a white light which is passed through the small hole. Now adjust the height of the prism such that the white light will be passed through this prism. After passing it, what do you observe? Yes, you observe the several colors. That means white light is divided into 7 colors, namely VGR, violet, indigo, blue, green, yellow, orange and red. And now we will discuss about another activity. Take a metal tray and fill it with water. Now place a mirror inside the water with making some angle at the water. Now place a white chart above the water level on the mirror. Now focus a white light passing through the water and touches to the mirror. What do you observe in the white chart? Yes, here also we will observe that the white light is divided into several colors, namely again with GR only. That means rainbow colors. Why? Because white light is divided into several colors. To know about this, we should know about the dispersion of light. What is meant by dispersion of light? The splitting of white light into several colors like with GR colors is called dispersion of the light. White light is a collection of some waves and with different wavelengths, like violet with low wavelength and the red at high wavelength. You know, the wavelength increases means the refractive index decreases. That means red light has highest wavelength. That means red light has lowest refractive index and also lowest deviation occurs in red. At the same time, violet has low wavelength. That means it has high refractive index and it has a maximum deviation. Now we will find the relationship between speed of the wave, wavelength and frequency. Speed of the wave is equal to wavelength into frequency. Now we will discuss about another activity. You need to stand near a white colored wall such that the sun rays will fall on your back. And now take a pipe which is flows with water as fountain. Now observe the colors that we see in the white wall. You will be observe that the white wall is covered with several colors with gear. Here the white light is dispersed into 7 colors. At the same way, the rainbow will be formed due to the dispersion through millions of water droplets during the rainy time. Now we will be explained about it by taking a small soap bubble. When the sunlight will fall on a soap bubble, the refraction occurs. At the first refraction, the white light is dispersed into several colors, with GR colors. And reaching the opposite side of the drop, each color is again reflected back into the drop due to the total internal reflection. At the reaching of the another side of the bubble, each color is again refracted into the air, but the angle between red and violet will be increases when compared to those at the first refraction. And we can see the bright rainbow when the angle between the incoming and outgoing rays will be nearly maximum 42 degrees. And to see the red light, we should see the drop. We should see the higher of the drop. And the red light will appear to us when the angle between incoming rays and outgoing rays will be 42 degrees. At the same time, we can see the violet color when the angle between incoming and outgoing rays will be 40 degrees. And the remaining colors of the rainbow can be seen when the angle between incoming and outgoing rays will be between 40 to 42 degrees. Understand? Now we will discuss about the scattering. You will listen that, and also you will have a doubt that why sky appears to be blue and why the sun will be red at the sunset and sunrising time, and also in hot summer days why sky will be white in color. Now we will discuss about all these through a term and phenomenon called as scattering. What is meant by scattering? When light incident on some atoms or molecules, size of these atoms or molecules is comparable to the wavelength of incident light, then some light is reobserved and some light is emitted. It is called, the re-emission of the light is called scattering. Now we will discuss about the reason for the blue color of the sky, white color of the sky in hot summer days, and the red color of the sun or sunrise and sunset time. First, we will discuss about the why sky appears to be blue. You know, atmosphere contains mostly nitrogen and oxygen molecules. Size of these molecules is comparable to the wavelength of blue light. So when sunlight incident on these molecules, these act as scattering centers and a scattered blue appears. So the sky appears to be blue. At the same time, in hot summer days, the sky appears to be white. It is simply because in hot summer days, atmosphere contains mostly water molecules. Size of these water molecules is more than the size of the nitrogen and oxygen molecules. So when sunlight incident on these molecules, different wavelengths are formed. Different wavelengths results in the form of the color white. So sky appears to be white in hot summer days, midday time. Now we will discuss about why sun is red in sunrise and sunset time. It is simply because the distance between the sun and the earth in the morning and evening will be maximum. That means there is a long distance. So we know that the wavelength of red is very high in the visible light. Such huge particles are very less in the atmosphere to capture this light. So, before reaching our eye, remaining all colors will be scattered and vanish, except the red color. So, sun appears to be red in the sunset and sunrise time. By this, we can conclude that why sun is red in color. Now, we will discuss about an activity to know about the scattering of light. Take a solution of sodium thiosulfate or hyposolution and sulfuric acid in a beaker. Now place this beaker in an open air where there is a availability of abundant of sunlight and observe the formation of the grains of sulfur in the beaker. As the reaction is in progress, the sulfur will start precipitates and the size of the sulfur will be increases. At the beginning, the color of the sulfur will be blue, and as the reaction is in progress and precipitate of sulfur occurs, then the color will be becomes into white. It is due to the scattering of the light.
You know what is the shape of the rainbow? It is not like a semicircle as you see, but it is a shape of three-dimensional cone. See the following figure, you can easily understand how we can see the rainbow. You know what is the shape of the rainbow from seeing it from aeroplane? Yes, it would be appears to be complete circle as shown on the screen.
Thanks for watching and subscribe for more updates. Thanks.